Ladies and gentlemen, welcome back to another edition of Tech in 10. This is basically the second part of my Supermicro C7Z170-OCE review. And I will be basically building a little system and showing you how to overclock a non-K series SKU on this motherboard. So it's kind of like a non-K SKU OC guide, a builder guide, and a little bit extra of a review of the OCE. Now, I have soldered on the back of the motherboard here. Let me see if I can get some better contrast on there. Yeah, so to the output capacitors I have soldered two cables, and this will give me voltage read point so I know the real V-core. I just wanted to check to make sure the V-core wasn't something insane, and it actually wasn't. Supermicro is pretty good, and so is CPU-Z at detecting Supermicro's correct core voltage. So let's first build this. First thing we need to do is install the CPU. Where did I put that sucker? There it is. So we open the socket, and let's see if we can zoom on up. Moving on up to the east side on a deluxe apartment in Sky. Sorry, I shouldn't be a singer. I should probably shut up. This is a Core Skylake CPU, a 6200, I believe, LE or TE or something like that. So we just place this in the socket and you just get it in there. You can close this, and as you close it, this plastic plate will pop up. That's how I always install the CPU. Next, we need to install the bracket hold down for the NH-D15, and you want to line it up and drop it in. You then put washers in each one of these, 4 corners, and then we put these little brackets on. And then we put these thumb screws in, because thumb screws are awesome. And some people have actually crushed CPUs installing coolers. Even with the NH-D15, which is a humongous cooler, your chances of crushing a CPU are slim. If you have a cheap Chinese knockoff cooler that is huge, or even that isn't huge, but doesn't have the proper guards. So for instance, when I screw down the NH-D15, there's only so far I can screw these screws down into these holes. I mean, on these, there's only so far I can screw these nuts down on the bolts here. And that prevents the CPU from being crushed, or the PCB from being crushed. And any socket can be crushed if there isn't this kind of like poke yoke. Basically a quality management technique to ensure standardization and quality management in the long run. So basically you cannot overscrew the NH-D15 or apply too much pressure to the CPU, because Noctua has designed the cooler to do so, to have guards against doing so in the design stage rather than final implementation. So they don't rely on this user to not apply so much pressure, unlike some cheap Chinese knockoffs, which probably do rely on the user. So I have this basically little tiny box of thermal paste I recycle because it's expensive. So I just apply a little dab there. And I know this is a kind of gross jar and it gets all over my fingers, but it's cheaper than buying a new $10 tube every day. So I just toss it on there and I screw it down, and I can only screw it down so much, which is the beauty of the system. And you'll notice that I will actually be able to install a full-size GPU because of the way the motherboard's layout is. I'll install a NVIDIA GTX 980, and it will be a top-of-the-line 980. No, not top-of-the-line. It's the standard reference 980. So you actually want to do both sides evenly, and sometimes it's hard to actually get it just right, but I got it right just right. And so it'll stop me from screwing too much right about now. Yeah, no, I'm skipping. So the cooler is installed, CPU is not cracked, broken, or messed up. And you can see that with the spacing here, there is enough room here to add a full-size GPU. So I have my nice nifty cheap Samsung monitor, which is all we need, and I have a test bench. So the test bench will sit here. I just plop on the motherboard, making sure that this doesn't touch it. I already have a Windows 10 ISO installed. I've already booted and done this, so hopefully we won't have any issues or errors. Okay, so now I have the system up and set up here. What do I need, right? I need memory. and I need a GPU. So, memory, you want to install in green DIMMs first, and basically the layout of the green DIMMs here is the same for all motherboards. You always want to install in these two slots of the distance from the CPU, so not the slot closest for the first two, and you want to skip one slot. So just green. Green is what you need to know for this motherboard. Installed. Power supply, 24 pin, installed. And now my GPU, GTX 980 from NVIDIA, installed. SATA. Oh, and this nice white SATA cable is from Bitphoenix. They have really nice extension cables and braided SATA cables. I really love them. Their cables are really nice, and they did provide them. I shouldn't say that. I should say that. That's what I'm going to put one fan because this CPU does not get hot even with the maximum allotted voltage the Supermicro allows me to apply. So now that that's in, I am now going to plug in power. And now I'm going to plug in HDMI. Where's my HDMI? Where are you? You're right there. Then we're going to plug in these keyboard, mouse, and let me get that digital multimeter. Any digital multimeter will do. This Radio Shack one is actually quite good. I know Radio Shack went out of business. They made some decent stuff. So I have extensions that plug into the probes, and that's all diddly-do. And now we have our keyboard and mouse. And I did forget something, which I shall not do. Thou shall not forget PCIe power, okay? PCIe power has been installed. Now, we are all ready to go. All that's left for me to do is engage power, power engaged, and powered up. System is powering up. Now there's two things we want to look at this point. We want to look at the postcode display, which is right here, and that tells us what's going on. And then the screen, of course. Right? So we're on 40, that's good. I believe I cleared the CMOS, I'm not sure. We'll be able to tell in a second, yeah. So first time after you clear CMOS or you set the base clock, it's going to reset the clock generator, and that's going to require more than one restart. This is my voltage meter. It will tell me the voltage of the CPU, 1.058. Basically, this is reset. So I'm going to go clear. This CMOS has just been cleared. The motherboard will beep, and then image will come on screen if the power is on. Yeah, I got to turn on power. That beep is from the system. And you can see this is the screen for the BIOS. Maybe I should kind of go down a little bit, right? Even with the... Sorry, I'm just a one-man crew here, and I don't have the nicest recording equipment. Hopefully I'll do enough of these videos and make enough to buy some new camera equipment, because I really could use it. But who cares, because this will do. Anyways, so we're in the BIOS, the UEFI for Supermicro. This is the first version, so yours might not be this. Now here's a trick. I always like to load optimized defaults anytime after I clear the CMOS and then restart. So I'm going to do that. F3 is load optimized defaults. F4 is a shortcut to save changes and exit. So I'm going to save changes and exit, go back into the UEFI, and then overclock the non-K SKU. This non-K SKU has a default clock of, I believe, somewhere below 2.7 gigahertz. I don't know. 27x is the maximum turbo multiplier for this 2-core, 4-thread. I believe it's an i3 or something. It's a 6200. I think that's i3. I know the high end real well. Low end is not really my forte, but you know, it's just a cut down high end. So we got the UEFI here. Maybe I'll show you some things if we have enough time. I think we're doing okay on time. You go over here to Extra Performance. You click Extra Performance, and over here we have base clock frequency. Now my default voltage, as you saw, the UEFI puts a little bit of load on the CPU, but in this case I'm just idling around 1.99 volts. In BIOS, I mean in Windows, I noticed under CPU-Z and I noticed in the digital multimeter that I was reading 1.05 volts. Now, you need that because that is your default vid at 27x, okay? And that means that's your basic default voltage. So you're only able to put an offset millivolt reading. So it's at 0. So the maximum, I believe, is 350. We will apply it. Now, there are base clock changes I can make to this locked CPU. They're between 100 and 200. I can't boot higher than 160. I'm going to hit 155 here. That should give us around 4.2 gigahertz. If you do the math, I'm going to go here with extra voltage. Now, for Supermicro, you want to delete what's in the field and then type in something new. So I'm going to type in 350. And that 350 will give me 0.35 volts extra. So that will be 1.4 volts. I do not need this much voltage, but when I go into Windows and load test, I'm still not even breaking like 6070C because the CPU core is so cut down. It's half the TDP, not half TDP, but temperature is much lower than it is on a Core i7, okay? Even with 1.4 volts, I am able to run it at full stability because temperature doesn't go that high. But the CPU is not the best clocker. System agent voltage, not important here. You can enable memory OC support, but I'm not going to mess with that now, and DRAM voltage is available. Now, there's nothing else you can do for overclocking this other than you can go to CPU processor and you can go to performance tab. Here you can change some of the flex ratio. This is the minimum allowable ratio that the CPU will go to in idle. Sometimes people set this, sometimes people don't. It's disabled here. These are all default settings. Virtualization, you can disable that. You can disable most of this stuff if you don't want to use it. Hyper-threading, you can also disable for a higher clock. Power management. Intel SpeedStep is enabled. C states are disabled. And CPU thermal configuration, you can configure the DTS, which is the digital thermal sensor on the CPU. I'm just going to leave everything like this because I don't care to mess with it. I'm just doing a simple little tutorial on overclocking this. I should also mention, if you go over here onto memory, that you see your DIMMs here, and then under memory config, you can actually set maximum memory multiplier. If I enable memory performance in the other menu, it will disable my ability to manually change the multiplier. If I keep that disabled in the extra performance menu, then I have these options. But as you can see, if I go to extra performance and I say memory OC support enabled, and I go back to memory, that option is no longer there. So that's something I saw. I haven't really fiddled with it too much. I'm going to CES tomorrow, so I don't have too much time to do this video, but let me show you this, because memory OC, I mean, you can tinker with on your own. It's the same on all platforms. It will be more limited on this. Keep in mind that your CPU core and your CPU cache ratios are locked, as are CPU power monitoring abilities, and that's probably why they disabled a digital thermal sensor. Basically, it doesn't work. When they hacked the BIOS to unlock non-K series SKU OC, they had to basically disable Intel's power reporting. So let's keep an eye on the digital multimeter. You will see that when I reset, okay, so I'm pressing F4 and I'm going to save and exit. We're going to boot into Windows. So you will see that this will shoot up to 1.39, 1.4. Yep, there we go. 1.39, that means it's applied. Looking at the postcode, we're going to go through a few restarts. Right now, we're at 40. We're going to go to BC. And BC is when it'll reset, yes. And then I'll boot up again, and I might have to, it might restart one more time before it boots. Let's see, because I hate restarting. Keep voltage in mind. See, here's a nice little trick. If you have active voltage monitoring and you don't have a postcode, you can tell if your overclock settings are applied or whether clear CMOS. No, it's working. We're going to boot into Windows. Okay. So, with a digital multimeter, you can actually tell if you're working correctly because the voltage will be what you set instead of default voltage that will be applied if the CPU is being reset. So if your overclock takes, you will have a higher voltage. If it does not take, your voltage will go low. That's just a little trick you pick up once doing this a lot, but you have to have the actual voltage, which is there. Oh, you better not update on me right now, Windows 10. That's really rude. I hate when Windows does this. You're trying to do something and then it's doing something like this. Getting Windows ready, I booted into you like a minute ago. What are you doing to me, my Windows 10? You monitor me, and then you spank me while I try to make a video. Anyways, so this is at 4.2 gigahertz. Let's just do the math. Maybe we might have to sit through this. Maybe I'll try to fast forward it. Please don't do that. Okay, thank God. Okay. So we'll do math, and then we'll go for the CPU Z surprise. That sounds wrong. Yeah. So I'm going to go down a little bit here. And and I'm going to try to make it so you can see much better. So let's load CPU-Z. I've installed a lot of stuff on here. Grand Theft Auto is on here. A lot of goodies are on here. This is just one of my test ISOs. Okay, so let's take a look at CPU-Z. Oh, there we go. I just overclocked the 6100TE. My bad, guys. It is an engineering sample, yeah. Max clock is 27x on the multiplier. You see here, 1.4 volts is what is reporting, and our digital multimeter is at 1.394. I'll light that up for you. 1.395, and we have 1.4 volts here. It is actually quite accurate. Also, power savings does not work when non-SKU OC is enabled. Max CDP 35 watts. That's why it runs so cool. So let me open Intel burn test, because we like to make it burn. It's gonna burn the crap out of the CPU. So running. Okay, so let's look down here. CPU, yes. So overclocking the CPU base clock also overclocks a system agent, which is also known as FCLK or F-clock. Some people, I think F-clock is traditionally used for representing fast clock, but there's no reference in any of Intel's material on what it is, other than some kind of communication bus between the CPU I/O and the PCIe Express controller inside the system agent. So increasing it, default is 800 megahertz, and you have the ability to go to 10x, or 8x is 800 megahertz with 100 megahertz base clock. But we increased the base clock basically 155, from 100 to 155. Looks like Supermicro has a base multiplier for system agent of 10x, and that basically means that 10x times 154 will give you 1.54 gigahertz instead of just 1 gigahertz, which is what most people get. CPU core on core 0 and core 1 is 4.2 gigahertz. Ring bus also 4.2 gigahertz. Memory is at base, so it doesn't overclock the memory at all. I guess that's what that DRAM lock was about. North bridge frequency, this is also cache clock, and that's at around 4.2 gigahertz. So basically that's that. What is the temperature, you ask, at 1.4 volts? Only 32 C on the package. On the cores, what is that? Cores is only around 35 right here. CPU motherboard is even warmer. So let's run just 10 loops. So we're running 10 loops of Intel burn test. It's burning right now, and we can see temperature does increase on the CPU, going to 42. It doesn't increase at all. And let's see power. Power consumption here is actually okay. Oh, see, all of this is disabled. All of this power reporting from the Intel CPU is disabled. I can only see temperature here, and it's probably the wrong temperature, but I don't think it's throttling. Oh, maybe that's why. Maybe I need to lower the voltage. Perhaps the voltage is too high. But anyways, this is how you can overclock it. It's just to show you how to overclock. I still got to refine it. Temperature is probably a lot higher than what's being reported because this is probably bugged. But I do see the package temp go up. However, if the CPU is getting really hot, I would feel it in the heatsink, and the heatsink's not getting very hot. Neither are the voltage regulators, and the CPU doesn't seem to be throttling. So everything seems to be okay, for instance. And plus, I can cool 1.37. Actually, look at this. So it's at load, and voltage has drooped. There is some LLC involved on Supermicro's board, so it's 1.376. Take a look at this. 1.376, 1.377, 1.376. This board is on point with CPU-Z voltage monitoring. Congrats to Supermicro. CPU-Z did not screw you over like they have on some other brands. However, we do have some excellent terrible results, but basically you can overclock it. You can really lower this voltage a lot. I'm just going max voltage because that's the maximum allowed, and I really wanted to see how high I could go. I couldn't go higher than 155, 160. So basically that's it. On the Supermicro C7Z170-OCE, we have the beautiful green board. This is Corsair RAM, not G-Skill. This is Corsair 266 megahertz. Oh, let me show you the light. So the light coming up from... Yeah, it's all good. So the light is actually quite powerful. You can see here that it's pretty good. I'm going to shut the system down so I can take out the GPU and show you the light and how it works there. The button, please go off. So you can see that the light actually does illuminate quite well, and this is a pretty bright light here. So removing the GPU, first GPU is also really easy with this board because I have this room here that isn't available elsewhere. So usually I can't get my hand in between the GPU and the Noctua NH-G15, but I can here. Anyway, so let's watch Super O go up. So unplugging power from the GPU, you kind of want to do that if you're going to do this. We don't need video because I'm about to end this. So ready, set, go. There you go, Super O is lighting up, and I really like it. I think Supermicro did a pretty cool job with this board, and props to them because they have really done a nice job with non-KOC on H and Z series boards. So if you have any questions or comments, please leave them, and I will answer them because you guys are my fans and I value your input. Anyways, please watch again for another video. Sin out.